how do we figure out chemical formulas? They can be determined from elemental analysis. What we get that way is an empirical formula, the lowest ratio of atoms of each element. So we can take a compound and decompose it and measure the mass of the elements that were in it, or we can take elements and react them together and measure the mass that reacted. We can also do it from percent composition information. So remember that the empirical formula gives us a ratio of atoms or a ratio of moles of atoms. It's not a ratio of the masses. We have to use moles. So here are steps for those of you that like steps. Start out with the mass of each element present in the sample. Sometimes you're given a percentage. If you're given a percentage, convert those to grams by assuming that you're dealing with 100 grams of the sample. If it's 57% oxygen, and you say, well, if I have 100 grams of the sample, then I have 57 grams of oxygen. So that's very easy. Just change the percent to gram. Take each of those masses and convert it to moles of that element by using the molar masses for each element. And then what your book says is write a pseudo formula using the number of moles of each element as subscripts. I don't like to do that, but that's what your book says. Divide all the subscripts in the formula by the smallest subscript. If the result is within 0.1 of a whole number, you can just round it to the whole number and be done. Sometimes the subscripts are not whole numbers. You might end up with 2.5 or 3.72 or something. Then you need to multiply all the subscripts by the same number until you get nice whole numbers. So here's a table showing different fractional subscripts and what you should multiply them by. If you recognize decimal equivalents of fractions, you'll see that 0.2 is 1/5, 0.25 is a fourth, this is a third, this is a fifth, well, it's 2/5, etc. If you don't recognize those, there's a very simple trial and error method. Try multiplying by 2. If that doesn't work, go back and multiply by 3, then by 4, then by 5. You almost never have to get that far. So let's do an example. A sample of a compound is decomposed in the laboratory and produces 165 grams of carbon, 27.8 grams of hydrogen, and 220.2 grams of oxygen. Calculate the empirical formula of the compound. So we start with masses of each element. Well, they're given to us in this problem. So I have 165 grams of carbon, and I have 27.8 grams of hydrogen, and I have 220.2 grams of oxygen. I can't figure out the formula by just looking at the masses or doing ratios of the masses. I need to convert these to moles first. The hardest thing about these sorts of problems is just remembering what to do. The individual calculations aren't that bad. So we're going to go from grams of carbon to moles of carbon. So we put the units in there, and then we know that 1 mole of carbon weighs 12.01 grams. That's the average atomic mass, the average molar mass of carbon. So we've got 165 divided by 12.01. If I was rounding, how many sig figs would I have? 3. So in these sorts of problems, if you round too much, you may come up with the wrong answer, because rounding can really mess these up. It's best to use way more sig figs than you need, because at the end it ends up being whole numbers and it doesn't matter anyway. I'm going to use the minimum, but go ahead and write it all down if you want to. So I've got 7.3, the 8 would round up to a 9, moles of carbon. Okay, so that's nice. I'm going to do the same thing with the hydrogen. I've got grams of hydrogen on the bottom, moles of hydrogen on the top. So the units cancel. 1 mole is 1.008. I've got 27.8 divided by 1.008. This would also have 3 sig figs. I'm going to keep a couple extras. That's moles of hydrogen. These problems get tedious. Science can be very tedious at times. Converting to moles of oxygen. 1 mole of oxygen is 16 grams of oxygen. 220.2 divided by 16. This one would actually have 4 sig figs. 7.625 moles of oxygen. Your book says make a pseudo formula. I think it's a waste of graphite or effort or something. Look at these moles and identify which is the smallest number. The one for carbon. 13.73 is smaller than 13.76. So I'm going to divide all of them by the smallest. What I'm trying to do is get the lowest ratio, because the formula C13.7, H27.6, O13.76 is not okay. We want whole numbers. So I'm going to divide all of them by the smallest one. So that one ends up being exactly 1. 13.739. So 27.579 divided by 13.739 equals. This one comes out to 2.007. And this one equals that's the balance. It's doing its cow imitation. So if you hear that during the exam, don't freak out. It's just the balance. 1.002. These numbers are all within 0.1 of a whole number. Within 0.1 means it's 2.1 or less, 1.99 or higher. Okay, so 1.9 or higher. So this can be rounded to 2, and this can be rounded to 1. And those are our subscripts. So we have C1, H2, O1. Just don't write the ones. Empirical formula. Any questions? Here's one with a mass percent composition. Determine the empirical formula. Same process. Instead of using the percent, 75.69% carbon, I'm going to say, let's say that we have 100 grams just to make things easy. Then I have 75.69 grams of carbon. So I've got that many grams of carbon. And I'm going to try to go through this quickly because we just did one like this. And those are going to cancel out. I'm going to set these up and then I'm going to do my math. 8.80% hydrogen would be 8.80 grams of hydrogen. Converting to moles. And 15.51% means 15.51 grams of oxygen. 1 mole of oxygen over 16.00 grams of oxygen. Bless you. So the first one I get 6.302248. Sometimes I just, write numbers down on these until I feel like stopping. Just too many is much better than not enough. This one comes out to 8.73016 moles of hydrogen. And this one, 15.51 divided by 16, 0.9693, what the heck, 75. Any questions? We need whole numbers, and so we're going to go with ratios. We're going to take the smallest number and divide everything by the smallest. So the smallest one is this. So that's going to end up being 1. You always get one of them that comes up exactly 1. So 8.7301 divided by 0.969375. This one comes out to be 9.006. This one .6.302248 divided by 0.969375 equals, this one comes out to be 6.501. So that's the minimum number of sig figs for that one, because it started with 4. The next digit is a 4. Well, let's put 2 more on there, just because that's what I often do, 3, 5. Can I round this to a whole number? No. It's between 6 and 7. I can't just say, well, it's a smidge closer to 7, we'll call it 7. I need to get really good whole numbers. I need to multiply this by something to get a whole number. So I see the 0.5, and I think that's the decimal equivalent of 1/2. If I multiply by 2, I'm going to get a whole number. If you don't recognize that, just try multiplying by 2. I still have that number in my calculator. I'm just going to go times 2 equals. Oh, nice, 13.003 times 2, 13.003. That can be rounded to a whole number. If I multiply 1 by 2, I have to multiply all of them by 2. So if I multiply this by 2, I'm going to get 18.012. Is that still rounded to a whole? I can still round that to a whole number, right? I can round that to 18. And then I have to multiply this one by 2, and that's going to be 2. So I come up with C13, H18, O2. Any questions?